So it's Saturday morning, got myself a pretty easy job, just putting in this valve actuator, floating valve actuator. It takes 24 volts to modulate the valve open and close. Pretty easy. This past week I was busy for about 4 days installing a control system for a hatchery setter. I don't know if you guys know anything about that. I got to learn a great deal about it, unfortunately. It's not really the easiest thing in the world if you're an HVAC tech. There's certain aspects of it that you gotta familiarize yourself with. As for example, the air conditioners where the setter is at, that room needs to be pressurized to a certain point, and on each end of the setters where they keep the eggs incubated, they have these plenum fans, which they're called plenum fans, but they're pretty much exhaust fans. Those need to be pushing out air from that end and exhausting it out in the roof. So essentially, while you're pressurizing the room, you're drawing air across the setters where the eggs are at, and it's being exhausted into a plenum out on the roof. So it's real critical airflow measurement. We're talking about like hundredths of what can I say? Hundredths of inches of water column. Yes, hundreds of inches of water column that we need to be able to maintain in the room, as well as their plenum. I know it's all a little convoluted. It was kind of difficult for me at first to get them going, but I feel now I learned a little bit more on that, and maybe I could probably do another one. Who knows? Depending on how they like the way it performs, we might get another contract to install another one. But regardless, I've got this one to install today in a church. We did an install on a unit, put a brand new unit in there, and came to test their valve actuator for their hot water coil, and we found it was bad. So I'm going to install this one for them today. So this is where your 24 volt transformer hooks up. You've got a hot, well actually right there, hot and common, 24 volt, and common, which is essentially just the ground. Then on the inside of here, you've got your 24 volt coming back out. That needs to be broken by a normally closed, normally open relay. Between B and W, you're going to energize this valve either to open or close. And on this point right here, I'll use a normally closed, normally open relay. On the 24 volt side coil, that's where I'll hook up my W signal coming from my conventional thermostat, so that way we can interchange between open and close, W and B. So pretty simple. I'm not sure how much I'll be able to record. Like I said, it's a church, so I'll try to record as best I can, you know, with respect to what they've got going on in there. Low limit and return. I'll plug that in. back seating. There it goes, slowly but surely. Okay, so I got done putting in this valve. Real simple three-way valve. The way it works, when the stem goes all the way front seat, we're bypassing the water from the boiler supply through this bypass line, and it goes back to the return back onto your boiler. When you backseat the valve all the way out, you're opening this connection between the boiler supply and the hot water coil to allow your hot water to flow in the coil while the unit's running, heats up the space, and then comes out through the return and goes back to the boiler. So real simple, easy to work with, and it's just a 24-volt signal that goes back and forward, either the front seat or back seat all the way out, and that's how that works. So if you got any questions, comments, go ahead and leave them. Appreciate you guys watching. Recap here. So the valve we put in today was a floating type. I've got 24-volt AC or DC. You could put DC coming from your transformer to the valve itself. Coming back out through point number 5 is 24-volt. You transfer that over to a relay, normally open, normally closed, to modulate your valve either fully open or fully closed. So pay attention to that, guys, when you get your valve. If it's direct acting or if it's reverse acting, it's going to be pretty important. That way you know either to send the power one way or the other. If you don't double check that, you might have the unit not heating when it's called for, or opening up and heating when it's not called for. So just pay attention to that. Any questions, comments, go ahead and leave them. Thanks.